Okay, so we have been given polynomials, and we have used those to graph them to find different things about them. This time we're going to be given the zeros and a y-intercept, and then we have to write the equation. So I didn't come up with a whole bunch of graphs on here because it was just easier to kind of do it this way. On Delta Math, though, you will be given a graph, and from that you have to determine the zeros, which is easy because you can pull them off the graph, and the y-intercept. But here I just flat out gave them to you. Okay, so what we know from, there you go, from what we've written down like a bazillion times is that our zeros, okay, these are our x values when we hit the axis, and they are written in the polynomial as x minus c, right? And that c is the same c that transfers us left and right, by the way, when we translate. So if I want to take these zeros and put them in this form, I can do that, right? I can do, and if this is a -2, so x minus a -2 is going to be x plus 2, right? Would I then have x plus 4/3? No, because we're not going to put a fraction in. Remember, what do? If we know that x, right over there, that means x equals a -4/3, right? So then we work it backwards, we get 3x equals -4, so 3x plus 4 equals 0. Just like on that last lesson, we don't get to just plop those fractions in there. So this gives me 3x plus 4, and then this is going to be x minus 2. Okay, so when we have that, a couple of things take care of themselves. Since this is my x minus c and that's my translation left and right, then whatever signs end up inside of all of that would take care of my reflection in the y-axis, and then it would also end up taking care of the y translation. But it is possible, like if I took my equation and I factored it out, and I factored everything out, I could have a number or a sign out here, right? And we don't know what that, like they didn't tell us what that stuff is. Well, the part that's on the outside there that affects it is the a, right? So we don't know what a is. But we have f of x equals this, and that's the best we've got so far. But I have this y-intercept. So since my y-intercept is 0, -32, then what does f of 0 equal? Exactly, thank you. -32. Like that's a super easy question because what I'm saying is when x is 0, what is y? Well, that's right there. So f of 0, when you substitute 0 in for x, you get your y-intercept. So don't make that harder than it is. Second period had to stare at me forever before somebody finally said that, so thank you. So that's what I know. So if I know that, then that means that my y is -32 when x is 0. Well, f of x is y. Right? So I can say, all right, well, if that's -32, then x has to be 0. So I don't know a. If I substitute 0 in for x, I get 2 times 4 times a -2. And then I only have one variable. I can figure out what a is. Right? So that means that -32 equals, well, 2 times 4 is 8 times a -2 is -16a. So a equals what? 2. So now that I have that, I can write my polynomial, and that is f of x equals 2 times x plus 2 times 3x plus 4 times x minus 2. And that gives me my vertical stretch or compression there. What questions do we have? Alrighty. All right, so then let's look at number 2. I have here f of 0 would equal -12, right? So I can write out my function f of x equals a times, then I'll do x minus 2 square root of 3, then x minus a -2 square root of 3, so that's plus 2 square root of 3, and then x minus 1, and then x minus a negative 1, which is plus 1. So plopping in those zeros should be fairly simple because we did that with the factorization on Friday, but we have to remember that that doesn't tell us everything. We have to take that y-intercept into account so that when I do that, if I make my y value negative 12, that's equal to a, then my x's are 0, so this is negative 2 square root of 3 times positive 2 square root of 3 times a negative 1 times a positive 1. So on my right-hand side, when all is said and done, is this number on the right going to be positive or negative? What do you think? Just, is it going to be positive or negative? That's all I want to know. Anybody? What's a negative times a negative? Positive, so it's going to be positive. So I can ignore my signs, which this means this 1 times 1 doesn't really mean anything, and I just need 2 square root of 3 times 2 square root of 3. So what's 2 square root of 3 times 2 square root of 3? Exactly. Anybody else? Okay, if you have absolutely no idea how to do that, then clearly you did not watch that radical review stuff that I have in there, and you need to, because I'm not going to work these out for you every single time. But to get that, 2 times 2 is 4, square root of 3 times square root of 3 is 3, 3 times 4 is 12, so this gives me 12a, which means a equals negative 1. So when I write my function out, f of x equals, my a is negative 1, so I just have a negative, then I rewrite everything. X minus 2 square roots of 3, x plus 2 square root of 3, x minus 1, x plus 1. And there you go. Okay. What questions do we have? Anything from anybody? All right, so let's look at number 3. On number 3, I've got my y-intercept, which is 0, 18, so that means f of 0 equals 18. So when I substitute this in, f of x equals a times, so x minus a negative 6 is x plus 6. Then I have 2 plus the square root of 5, 2 minus the square root of 5. So I'll have x minus, I'm going to substitute something in with more than one term, so I need parentheses, 2 plus the square root of 5, and then x minus 2 minus the square root of 5. And I meant to say, I don't know when you printed that out, but you might have been listening. No, you okay? Because I decided to change it at the last minute again. Okay, good. All right, so now I'm going to distribute this negative. So I get f of x equals a times x plus 6 times x minus 2 minus the square root of 5, and then x minus 2 plus the square root of 5. So now that I have that, I'm going to substitute 18 in for y. That's equal to a times 6 times negative 2 minus the square root of 5 times negative 2 plus the square root of 5. So looking at these two binomials here, what kind of setup does that look like that has come up a lot, but we usually have variables in there? Any ideas? what if negative 2 is x? So I just have x minus, and let's say that square root of 5 is 5. So x minus 5 times x plus 5. What's that called? It's a what? Okay, it does the factored form of what? Like if to multiply those two together, is that pretty easy? What does this give me? It's a difference of squares. This gives me x squared minus 25, right? So this is a difference of squares situation. We agree with that? Okay, now that's not actually like part of that problem, but the concept is, because this way we should totally get it, right? So then here, if you look at this, I have something, basically I have a minus b and a plus b. So that is a difference of squares. So I can treat it like that. I don't have to do anything crazy there. So that means I'm going to still have 18 equals a times 6. And then difference of squares says you square the first one, so negative 2 squared is 4, minus, and then you square the second one. What's the square root of 5 squared? 5, right? Squaring a square root's easy, it's just 5. So 4 minus 5 is a negative 1, so it'll be a negative 6. So basically I have 18 equals negative 6a. So what does a equal? Nobody's brain is awake yet? 3, negative 3. So there's my a. So that means that f of x is equal to negative 3 times x plus 6 times, and then I can do either form of either one of the green ones. I'm going to do the second one because there's less parentheses. X minus 2 minus the square root of 5, and then x minus 2 plus the square root of 5. Okay. What questions do we have? Okie dokie. Now, in number 4, when I edited this, I have a hard time with that word, I left something off that I meant to edit. This 0 was supposed to be a negative 3. So if you'll change the 0, you don't get to willy-nilly change numbers, only because I'm telling you can change it. So my y-intercept is negative 15, then f of 0 equals negative 15. So I'm going to jump in and start writing this stuff down just like before. So f of x is equal to a times, so this is a negative 3, this will be x plus 3. Then I have this 1, so it's x minus 1. And then what do I put in there for the 5 halves? Because I don't put x minus 5 halves. Thank you very much, 2x minus 5. And then it says multiplicity of 2, so then I also need to square it. Okay. Everybody good so far? No need to actually square it out, though, to work it out. Like, I can leave it like that. That's totally fine. And I don't have anything inside of these to simplify. So now I can substitute in negative 15 for f of x. It's equal to a times, when x is 0, I get 3 times negative 1 times negative 5 squared. So on the right-hand side, my final answer over there going to be positive or negative? Negative, good, because you're going to square this. So this is going to be 25 times, so it's a negative 25 times 3. What does that give you? If you have 3/4, how much money do you have? 75. I'm sorry, what? Well, it's negative after it's positive when you square it, and then negative when I multiply it by the 1. That's where my negative 25 came from. Negative 25a. So then I need to divide both sides by 75. So I know a will be positive. So when you think in terms of 25s, you should think money, right? Because that 3 times 75 is 75 cents. But what do we use every day, all day long, that we think in terms of 15s? Time, exactly. So we know in an hour, how many 15-minute intervals are there? 4. So 4 times 15 is 60, but I got to get 75. That's 1 more, right? So is my answer 5? What is it? It's 1/5, exactly. So when you think that way, make sure you put the fraction right there. So it's 1/5. Very good. So then that means that f of x is equal to 1/5 times x plus 3 times x minus 1 times 2x minus 5 squared. What questions do we have? Anything from anybody? All right. Then I want you to do number 5 on your own, start to finish. Okay, what questions do we have? Anything at all? Make sure we agree. Okay, we all good? Yes. Awesome. All right, so let's talk about our complex zeros. So we have the conjugate root theorem. Conjugate should not be a new word for you. If a polynomial function has a complex zero at a plus bi, where b does not equal 0, which basically means that it's going to be an imaginary number. Okay, so if you have a 0 there, then its conjugate, so if I have a plus bi, its conjugate is a minus bi, is also a complex zero. So basically, if you have an imaginary root, you have to have it. You can't just have one. You're going to have two. You're going to have even numbers because they'll always be the conjugates of each other. So when they give you these roots, they're not necessarily telling you that it's all of them. When you look at number 6, they gave me plus or minus the square root of 6. Then they gave me 2i. Well, since 2i is one, then negative 2i is another one. Okay, and we're not adding it just because I'm telling you to, because I left it off, because I left it off on purpose, because you need to know from this theorem that if you have one, you have to have the other. And then we also know that f of 0 equals 12. Okay, so y'all go ahead and fill in your initial function without me talking you through it. So in this case, we're just plopping them in those little binomials, and since we have the plus or minus, the signs are pretty hard to mess up at this point. So now that I have that, I'm going to use my y-intercept. So when y is 12, x is 0, so this will be a times negative square root of 6 times positive square root of 6 times negative 2i times positive 2i. So what is negative square root of 6 times the square root of 6? Negative 6, exactly. Anytime you multiply two square roots that are the same, you get the number that's underneath them. So this is just negative 6. Then when I multiply these, what's negative 2 times 2? That gives me a negative 4, right? What's I times I? That gives me I squared, which is what? Negative 1, exactly. So that means that I get 12 equals, that's going to be a negative 24a. Then you should be able to finish this up. Okay, what questions do we have? Okay, so once I was done, somebody called me out on this because I totally messed this up, so let me correct this. Clearly, since this is square root of 6 and so are these, this should be as well, and for whatever reason I left them off, so make sure that you have the square root of 6 in there as well. Okay? All right, so let's look at number 7. Ooh. Since they gave me all of this, I know another 0 has to be what? What's a missing 0 on number 7? If I have an imaginary one, I have to have its conjugate. What's the conjugate of this? 3 what? Minus I, exactly. So I actually have 3 zeros here. And then I know that f of 0 equals 10. So f of x is equal to, so x, oh, I've left off my a. Hang on. Oh, come on. A times x minus a negative 4 is x plus 4. And then I have x minus this, so minus parentheses 3 plus I. And then x minus this, parentheses 3 minus I. And then rewrite this by distributing your negatives. All right, so now I'm going to substitute in my y-intercept. So I get 10 equals, I have a times 4 times negative 3 minus I times negative 3 plus I. So these little binomials here, again, are what kind of situation? What do we call it? Difference of squares, okay? So I'll have 10 equals a times 4. So I can square the first one, that becomes 9, minus, and then when I square I squared gives me a negative 1. So this becomes 10 times 4, so I get 10 equals 40a. So a equals 1/4. And then you can rewrite it with your a using either one of the green ones. I would use the second one because it has less parentheses. So f of x equals All right. What questions do we have? Anything from anybody? Hello? No? We're all good? All right.